Okay, so we've got a little too much carbon dioxide, and it's making the world a little warmer. But is it really a big deal? How much warming are we talking about? How much have we warmed so far? According to an ongoing temperature analysis led by the scientists at NASA's Goddard Institute for Space Studies, the average global temperature on Earth has increased by at least 1.1 degrees Celsius, which is 1.9 degrees Fahrenheit, since 1880. Even if we round that up to 2 degrees, maybe that doesn't sound like much. But think about that in terms of your own body temperature. 98.6 degrees is normal. If you add 2 degrees, you're at 100.6. You're running a fever. But that's just the average. What if during a 24-hour period your temperature is also fluctuating wildly? What if that fever, average fever, includes your body temperature running first at about 92 degrees for several hours and then spiking up to 107? Obviously, that would not be good for a person, and it's not good for a planet or ecosystem. Let's take a closer look at the warming that's already happening on Earth. To really understand that amount of warming, there are a few things to consider. For one thing, that change is not distributed evenly around the globe. This map, courtesy of NASA Earth observations, shows the ground surface temperature anomalies around the world. This is not a map of total climate change or total temperatures. It's just the difference in surface temperature in April of 2023 as compared to average April temperatures between 2001 and 2010. So it's only showing very recent, relatively short-term change. But all the reds and blues does give you a visible demonstration about how unevenly temperature change occurs around the world. Note that this map is showing the temperature anomaly in the spring of 2023, but I've made the link to the interactive web page available to you in the connections page, so you can look at other time frames as well if you're interested. But if you look closely at this map, you'll notice where the biggest, densest blue blob is, right over a big portion of the United States. Where I live in the northern Great Plains, we've had some really weird cold spells, especially in the spring. That isn't a reason to doubt that climate change is real. In fact, this is an unexpected impact of global warming. We'll talk about that a little bit more later. But in any case, if you happen to live in this part of the world, you may possibly not have felt some of the same climate impacts as what other parts of the world have been experiencing. But if you've been paying attention at all, you'll have realized that a lot of crazy stuff has been going on all around the world tied to the climate. But what's another thing that pops out on this map? Do you notice the large areas of gray on the map? Of course, you can see that those areas are the world's oceans. Since this map is concerned with land area, the ocean temperature anomalies aren't shown here. But when you think about the magnitude of temperature change on the Earth, it's important not to forget about the ocean. Water doesn't behave the same as air or solid surfaces when it's exposed to heat. Water is very good at absorbing and holding heat. When the radiant energy of the sun hits the land surface, some of that energy is absorbed and some is reflected back into the atmosphere or back out into space. Water absorbs and stores much more heat than the other surfaces and substances do, and much more than air. If you're a gardener, especially in the northern part of the country, I'm sure you've seen a product called Wall of Water. It's a ring of plastic tubes that you can fill with water and put around your garden plants in the spring so that you can get your garden started early while there's still a risk of frost or too much daily temperature variation for baby plants to manage. That wall of water around the plant absorbs heat from the sun all day, even if it's not very warm out, and then slowly releases that heat all night, keeping your tender little plants safe and warm. The ocean does the same thing, but on a huge scale. It absorbs heat and stores it. So the measured change in global land surface temperature is missing all of that heat that the ocean is storing. There's a lot of energy there. Think about how huge the ocean is. It covers over 70% of the surface of the globe, and it's deep. So beyond the surface area of the ocean, think about its volume, which is holding all that heat. The ocean is 320 million and 3,271 cubic miles of water. That's over 315 quintillion, or 352 billion million gallons. That much water can hold a lot of heat. In fact, approximately 91% of the heat stored by the Earth is held in the ocean. That's heat that does not figure into the 2 degrees of global temperature rise, because that number refers to temperatures measured at the surface of the planet, not underneath the waves. But just because that heat has been tucked away in the ocean doesn't mean it is tucked away safely. The oceans play a huge role in the weather that we experience on land, so we're going to have to talk about that in a little bit. So while we have been slow to notice the effects of the warming of the planet because so much of the warmth has ended up in the ocean, we shouldn't let this fool us. Remember, that wall of water in the garden works by absorbing the sun's heat in the day so that the little plant doesn't get too hot, but also by re-emitting that heat overnight, keeping it from getting too cold. In the same way, the ocean will not store all of that excess heat forever. In fact, it is slowly re-emitting all that heat all the time, but we've been slow to notice. Just recently, there's been a scary spike in observed ocean temperatures, which suggests that we may be feeling some overdue effects of that heat sooner than later. Look at this graph. This shows the average sea surface temperature, not counting the polar regions, for every single day since 1981 by calendar date. This dashed line in the middle is the mean value for each calendar day between 1982 and 2011, used to represent the long-term average. This thick black line up here, that's where we are so far for 2023. As you can see, our ocean surfaces are way hotter than they've ever been. So warm air and warm water. So what? What do warm air and warm water do to the environment we live in? That's what we're going to be talking about, but here's a very quick and extremely incomplete list of things just to think about that a few extra degrees in the temperature of the air and water around you might be doing and how they might affect the world around you.